So I'm going to use the recorder for GoToMeeting. Okay, so we've got two options. Okay, so the common questions that we get related to driving sketches, obviously, is what is a driving sketch part? I've been in arguments with people over what a driving sketch part is and what a driving sketch is. So we'll show you what that is. Where is the best place to create driving sketches? Where the best places are and what they're used for? And are there any rules that we need to follow while we're creating driving sketches? Those rules are very important. And what is a member sketch? And then obviously, how does a member sketch work? And how many member sketches can you have? Are there any rules for member sketches? And where are member sketches used? What sketches are used in connections? And if you work on multidisciplinary large projects, how do you set up your driving sketches? So these are just some fundamental questions that we get asked from our customers all over the world. So I'm just going to go in and you can have a look at what these answers are, and then what I'll do is I'll toggle backwards and forwards with SolidWorks in and out of the basic slideshow. I don't want to give you a slideshow of death. I don't do that. I just cover the main points and then we go into live demonstrations. Okay, so I guess the first question is what is a driving sketch part? So a driving sketch part contains one-to-many sketch features. So it means you may have just one sketch feature with a sketch in it, or lots, and you can put that in one part. Now, a driving sketch part can be added to parts library so that you can reuse it over and over again in your projects. Anything from trusses or even just down to setting up basic grids for buildings and things like that. Now, driving sketches are what we drive and attach the steelwork to. So we put all our steelwork on this frame, and we can change dimensions that will move the steelwork around. Now, I find it best to use driving sketches because it's much more stable over mating alone, because you're obviously going to be mating to sketch lines, and the sketch will move your steelwork around. Whereas if you're just simply mating one item to the other, you can get some nice results if you're not too careful. Okay, I'll show you what a driving sketch part is and what it looks like. Now, the best place to create a driving sketch is in a part. However, driving sketches are used in project levels, area levels, and member level assemblies, and how they are used in those areas or in those assemblies is up to you and how you do it. What we will show you is a way that we do it, and if you follow the way we do it, then when it comes to assessing any issues that you may have, we can pretty much easily answer them for you. So if we're all doing the same thing, we experience the same result. So when we're creating an area assembly, it's best to use the TSD members blank member. This will insert an assembly to contain your driving sketch part, and then you can keep adding more parts to it if you want to create different parts. It's also recommended to create a driving sketch part. However, at weldment member level, assembly sketches are okay. So you can put sketches in your assemblies, but I don't recommend putting them in there. The good thing about putting them in a part is we can upload it to the library. If you put it in an assembly, it means that you've got to upload that member to the member assembly library along with all its parts, not just the actual sketch itself. And then if you insert that into a project, then you might have to remove the parts that you don't want. Hence the reason why I say stick it in a part, put it in the part library, and then you can reuse it. Now, the rules for driving sketches. Yes, there's certainly some rules that you have to follow. Now, the direction of the sketch segment that you put in a sketch is really important, because that's the direction to which, when you attach your welded member to or your section to, it's going to stretch in that direction. So obviously where you start your sketch and where you finish your sketch line is crucial. Generally, the rule of thumb is to draw a sketch line segments that anything's vertical. We start from the bottom to the top, which would be the stretch direction. So if you're going to put a column in, it would stretch from the base plate to the top of the column. And horizontal items or slope left to right, it depends on where you're looking. However, as a rule of thumb, we go from left to right. If you're outside of a structure and you're going around the structure, you might want to go left to right. It's all up to you, but we stick to that sort of convention because that's how we model our welded members. The length of a sketch segment also will determine the length of your welded member, so that when you insert your welded member on your sketch segment, the last thing you want is a really large length column that you just can't water or transport. So think about how you would do your driving sketch. I've seen people put grid lines on for columns that go from the bottom of the structure all the way to the top of the structure, and they're going to be 50 metres long. Well, you might want to put a splice point in there somewhere, or two. You can use 3D sketches, but from my experience, I prefer 2D sketches because it's easy just to peel back the feature tree, and if I need to find something relatively quickly, it's easy to do that. You can break up your 3D sketches and get the same result. However, when you're on planes, you can swap sketches on planes fairly quickly with 2D stuff. That's just a personal preference for me. Okay, so a member sketch. Okay, we've done a driving sketch. A driving sketch is what we attach our members to. Now, inside a member or a section, we have what we call a member sketch, and they're also in connections. A member sketch is what snaps onto your selected driving sketch segment. That's basically what it is. It snaps on. So what it does is it creates, and that's the next question I think is the answer. So how it works. So by selecting the member sketch, the driving sketch segment, when you go to insert the part, or when you go to duplicate or copy your welded member into your project, it will attach the member sketch to the driving sketch. Hang on, we'll just get rid of that. And it will attach it by putting in 3 mates, and it will also put in a relationship of equal length for the first selection. We have several selections, so I'm just going to tell you that that's the first selection. The second selection gives you a different result. The second selection will allow you to make it parallel, and I think there's another one in there, parallel, and I think it might be equal. I'm not sure, but it does both. We'll see when we get in there, and I'll show you what it does. Okay, so how many member sketches can you have? Now, you've probably seen in our trial library the stairs and the handrail. The stairs themselves, obviously you can see that there's going to be 2 member sketches. The 2 member sketches that TSD uses to position, because there's only 2 that it uses, member sketch and member sketch 2. However, you can have as many as you like after that, and just for consistency purposes, we go member sketch 3, and then the little man that we put on the end, you can type manual if you want, but we just let our guys know that it's manual. It means that you need to manually attach that. It can be equal. It's up to you and how you set that up. You can put a little description on the end that says equal relationship required or something along those lines. So there are 2 fundamental member sketches that are required. If you don't use 2, you can use 1. That's fine. One for beams and that sort of stuff. You'll see that you've attached. If you've had a play with a trial library, that's fine. But you can use 2 if you need the second one. It's an option. Now, when you do set things up and you are doing your member sketches, you've got to make sure that the very first one is a horizontal one or a vertical one. Okay, the second one can be diagonal and it can be vertical or horizontal, but the first one you don't want to make diagonal because it'll give you unrealistic results. It'll put it in a really strange place. If you make it horizontal or vertical, you're basically telling TSD, or TSD is telling you by doing that it's going to position it in that direction. Okay, so if you set up your stairs on a diagonal line, the diagonal line could flip your stairs around in a strange result, whereas if you were to set up your member sketch on the horizontal, which is the first selection you see there in those stairs, that will position it for you automatically. So basically that's how member sketches work. We'll show you how that works and what's involved in creating those in a second. Okay. Now there are rules for member sketches, and they're very important rules. Okay, I'll show you how you can check those rules to make sure that you've actually got them right. So a member sketch only contains 1 sketch segment. Okay, and 1 sketch segment only. That means that there's no sketch points, nothing else, and it has to be the first sketch segment. So if you go and put in a sketch segment and then a second one and delete the first one, you've got to get out of the sketch and start again. So create a new feature again and put in a sketch segment. It has to be line 1. I'll show you how you work out whether that's line 1 or not. It's quite simple. Some guys already know how to do that. I'll show you how that's done. You can't add anything else in there. It's just a sketch line, because that sketch line is used to attach to your driving sketch. That's at the welded member level and the connection level, okay, and also the section level. The direction of the member sketch is also very important, because that's the direction to which it's going to stretch. Now, for our columns, we draw our member sketches from bottom to top. So it means the top's going to stretch. So when we go and snap that onto a driving sketch, it's going to stretch to the top and keep the base point where it belongs. And now, all of our members, all of our braces, all of our trusses, stairs are a little bit different because we've got two member sketches to drive that, but most of our trusses that are may even be diagonal, we draw horizontally in the member sketch, in the member weldment under the member sketch. The reason for that is because when you go and put that on a drawing, essentially you don't want it rotating up on you. You want to have it so that it's horizontal and the ends do the rotation. That way your detailing and your dimensions and everything are not going to get thrown out of whack if you actually change it. Which is a problem that you get with relative views on multi-body parts for detailing, which we avoid. All of our member sketches inside of our sections are either horizontal or vertical. So just consider that when you do your own member sketches, that's what they are. The other important thing is obviously the name of the member sketch, okay? The name has to match exactly what is written, member sketch, with the space, capital M and a capital S. And obviously the next one, being member sketch 2, has to have a capital M, capital S. What will happen is if you don't name it, TSD won't know it and it won't be able to attach it for you because it's looking for those names. Okay? Now, member sketches are used in both members and connections, and I should also state they're also in sections as well. Obviously you've got to go down the tree. If you go to the assembly, which is the welded member, down to the part, the component, you're going to get sections, and then down into the connections. We'll certainly go into that and I'll show you that in a sec. Now, sketches in connections. Sketches in connections can be member sketches as well as sketch points. When you insert a connection, TSD puts a 3D sketch point inside the welded member to which the connection's been inserted to, and it incontextually links that sketch point to the driving sketch. And then inside the welded assembly, it attaches the connection to that welded assembly sketch point. Okay, I'll show you that in a sec so you can see how that works. And obviously there's member sketches inside your connection so that you can set up things like braces shown in that that base plate down the bottom there, and also in the truss that's going to have a slope on it. And they are manually attached. Now, if you work in a multidiscipline project, you want to know how to set that up. I'll go over it in brief. Not a lot of our customers work in multidiscipline projects, but if they do, all you do is just put your hand up and we'll run them through how to set it up. Today I will cover as much as I can on it. It's not difficult. It's quite simple once you understand what it is that we're trying to achieve. Okay. Now they are set up differently to someone who's working in one area. Okay. So I will show you that later. So let's just go through some of these points. So the very first, the rules. So the best practices or the best place to create a driving sketch. So let's just go through this process on number 2. Okay, I'll fire up SolidWorks. There we go. So I've logged into a project. If you're not familiar with logging into a project, it's when TSD projects, and I'd already created this project, and then I just go project login, and I've logged into area AA. So this is just an assembly, area AA, and in there I don't have anything. So the very first thing that we need to do is either use a driving sketch from the library, which you already would have covered through your tutorials. Okay, it shows you how to grab a driving sketch that's already been created and put it into your project. However, I'm going to start from scratch, and I'm just going to show you a couple of things so that you're familiar with the tips that I'm just going through in this tutorial today. So TSD members, and I'm going to put in a blank member, okay, to start me off to get my driving sketch happening. So we go into structural, and in here I've got DS, which is set up for driving sketch. Okay, that's the code, and I'm going to put in a blank one. So I just hit my tick, and that creates a driving sketch. Now, this is an assembly. Everything in the area is an assembly. You can drag parts in, but just make sure you exclude them from BOM. And if you're going to create a driving sketch, it means that you don't want anything in it. So you just right mouse click, and you don't want to have this coming through into your bill of materials at any stage. So we just exclude it from BOM. Now that overrides anything down below as far as parts go, but however, I like to just make sure that everything is excluded from BOM in there. So when I created this blank member, it dropped the member in. It also dropped the part in for me to draw my driving sketch. Now, to show you that it's important that you select the right direction, I'm just going to put in a sketch here, and we'll show you what can actually happen. So if I, let's just say I'm going to draw in a column, and if I go in the opposite direction, say downwards rather than upwards, and it doesn't look like my dimensions are set, so I'm just going to set that. So we'll make that say 3 meters, and that's in reverse. So I started at the origin and I went downwards. Now I name all my sketches by habit. If I don't, it means I'm being lazy, and I'm also being inconsiderate to someone else that may pick up the project and work with it, especially if you work on a team. Okay, so I'm just going to call this column sketch, so we go straight to it. I'm going to close that part off, go back to the area assembly, and now I have a driving sketch. I'm just going to demonstrate what can happen if you don't set it up right. So I'm just going to my library, and I've picked up TSD members, and I've gone into columns as a default, and I've got a few columns in here to which I can select from. I'm going to pick that one and then select the line. I've drawn this upside down. What happens? My column's upside down. Straight away I go, oh, that's not very good. That hasn't worked. Now there's two options. You can grab the driving sketch and flip it around and swap the direction to which it's going with the member here, and then try and fix up the member after it, or you can simply just go into TSD members and go delete member and remove it, and then fix up your sketch. Okay, by fixing up the sketch, we can now attach the column to it. So go back into the columns, select my column, and now it'll be the right way around. Okay, see how that works? Now, that is how we insert items from our library onto a driving sketch. You'll notice in the process, and I'll do it again so that you can see what I did. Go to delete member, members, columns. When I select my member, you'll notice that I don't scroll all the way down because the default setting is sketch segment anyway. So basically I'm going, I want to select a sketch segment. These are the two sketch selections for the driving sketch segments that I want to attach my welded member sketch to. And then I just pick one. I don't need to pick the second one. It's an option. In this case, the column's only just the one. Now let's go in and have a look at this column. Let's open it up. So you'll notice the member sketch. So when I open up that member, you'll notice now that the member sketch, when I go to edit it, one line segment. And if you want to find out whether it's the first line, you simply use the measure tool. The measure tool gives it away, and you pick the line and it tells you line 1. So it tells you it's the first line. We need it to be the first line and the only line. And you'll also notice that when I pick it, it's got an equal radius length relationship, equal length relationship in there. So when we insert it from the library, TSD has made that relationship to the sketch driving sketch segment that I've selected automatically for us. Now you'll also notice that down inside the section there is also a member sketch there too. And this member sketch is attached to that member sketch. So that way when you do a rebuild at the top level, it rebuilds down the tree. That member sketch also has an equal relationship to this member sketch. So you can attach to member sketches as well. Now you'll also notice, just through the connection that you see up the top here, we have connection points. Right? You probably can't see it, but it's just there, it's in the green. However, if I was to edit it, there it is there. And that point there is actually coincident to the member sketch. Watch what happens when I take away the relationship to it and drag it out and then do a rebuild. Okay, my connection is attached to that sketch point. When you insert a connection into TSD, it will create that sketch point and it will match the name of the connection. So in this case we've got CNO2, which is the second connection in sequence, and then CP01 is the library code for connections, and 01 being the sequential number. So if you've got two, in this case, cap plates, that's what the CP stands for, it will automatically bump up CP01 to CP02 for the next one. And the base plate's got the same thing happening with it as well. So if we go down to the base plate, we grab the coincident point, drag that out, and everything is attached to that as well. So we do a rebuild, and that pulls that out there. Quite a simple process, nothing too complicated about how TSD works in that respect. Once you get familiar with how all the components work with one another, you can simply go into the area assembly, and if you're going to remove connections, you can pick these connections that we've got here, and that'll take them away. And obviously with that, we've got to take away the trimming components that are associated to that, so that brings that back to its base component. So that driving sketch that I created, that's only got one line in it, or one sketch segment line in it, and we do sketch segment lines only with our members, by the way. We do not do arcs. There is a process for arcs. It's another sketch, but the member sketch is between point A and between the 2 points, 1 and 2, and there's always a straight line between the start and finish of an arc. The arc itself can have a member sketch as a radius in it, and you can actually use that in your driving sketch to snap the member sketch on. Tutorial number, there's one in there. There's a tutorial we've got in the list that shows you how to do a curved member as such. Okay, so you can see that just through stripping out my connections, I've removed them, and the only thing that's left is my member, and my member is attached to my my section is attached to my Welded Members driving sketch, and they're all linked to one another. What if I wanted a section that I wanted to reuse over and over again? Well, let's just go into my section here, and when you go to upload to the library, you have to remove the member sketches and allow them to float, because they snap on. I'll show you how that works. So here's a column, and in my parts library, and if I haven't set it up right, you'll see, and I'll show you how to set it up. I'm going to upload my part to the library, a structural component, and in there I should have sections. So I set up a code called sections, and there it is, section, and you can create your own filter. So before I upload this, I just want to make sure that the drawing behind it is okay, so we can just open the drawing. Okay, just make sure that that's okay. It's got a dimension on it. We can tidy it up a little bit. So there's the drawing in the background, and we simply just click my tick. That adds it to the library under the sections. So what this means is that now if I was to go back into my member sketch, my weldment member, I can build my frame quite simply off a member sketch that's already in there. So I can peel all this back, and this is a driving sketch within a welded member. Okay, and you can do this at the assembly level. It's not a big drama. Or you can actually insert a driving part. I know that might be a little confusing. At the end of the day, once you see a couple of these, you'll go, okay, I understand what's going on. So I'm just going to draw some lines, and you'll notice that with my member sketch I went from left to right at the base, and then I went from bottom to top. I'm now going to drag that up over the top here. You'll notice I did that out off the side, and that's because I didn't want to create any relationships to it, so I could drag it up the feature tree. Okay, and in this I've got hide all types, so I'm just going to turn all that on. And sometimes when you do a Control Q and a Control S for save, you may not be able to pick the sketch lines when you go to insert your parts. That means you have to get out of the assembly. This is a little bit of a bug, I think, in SolidWorks. However, when it happens, just get out of the assembly, get back in again, you'll be fine. So in our parts, because we're in our welded member level, we can actually go insert a part. You'll notice I've got some sections in here that I can use, and I'm just going to go, see how I can't select it? No, there we go. Let me select it. It's good. Sometimes I can't select it. You'll now notice that when I go to insert that component, it's automatically added the relationship. And my sketch here, I can go set out sketch and give that a name and put some dimensions on this thing so that it's fixed. And SolidWorks likes to, what's that done? Shrunk it right down. Yep, 5 meters. Silly bugger. And 2 meters. And that'll pull it back out again where I wanted it. Okay. So you can see how my driving sketch is now attached to the whole process. Now I've got my driving sketch here and I've got my member sketch driving my driving sketch. That's what we do with welded members. So if you wanted to do a frame of some sort, just create a set out sketch and your member sketch is there. Now you can set it up so that the bottom line is also a second member sketch so that you have 2 items to select. I'll show you that in a second so that you can see how all that works as well. That's how you create welded frames, okay? Now, the member sketch that I have, sorry, the driving sketch that I have in here obviously can be a myriad of things. It can be a grid for a building. It can be a complete frame. I've got some frames here to show you so that you can see how they're done. Let's go into a frame project, so I'll log into that. Not that one. I think under 2. And I can preview it. Okay, so there's a frame there that I've been adding bits and pieces to as a bit of a test environment for me for locking and unlocking. And you can already see that there's a frame in there. This can be a driving sketch, and you'll notice that it's excluded from BOM. And I've got my driving sketch part, and in here I've gotten lazy. As you can see, I've not named my sketches. And you can see that there's a driving sketch for a set of stairs. Now, for a set of stairs, if you looked at that image that I had there earlier, let's go back, scroll down, there are 2 driving sketches that are required, 2 driving sketch segments that are required. So I'll just pull that back off, and this one here and that one there are required. So I draw the vertical line in just to close it all off. Sometimes that might confuse people, but it's not that confusing when you go into your stairs and there is a my library is not up to date. There is a set of stairs here, and there's usually one across the bottom and one in the diagonal. So it means that when I select my stairs, I select my horizontal and my diagonal. You'll notice I've got 2 selected, so sketch segment and then 2 selected, and that'll put my stairs in for me. The first line across the bottom positions it, like I said before, and then the diagonal line pretty much sets up the slope of my stairs. So if I go to the driving sketch, which is associated to that, and if I'd labelled them, I would have been able to go straight there, and you can see that the driving sketch is fully restrained. Now if I go into the stairs, you'll notice I've got member sketch 2, okay, and if I go into member sketch 2, these are the relationships. There's an equal and a collinear, like I said before. Yep, that's right. So it means that if I change my driving sketch, it will automatically update. I don't know how this is going to go, but we'll give it a go because it's got preconceived stuff in there before. If I change that dimension there, it means that when I get my height changed, my stairs will automatically rebuild as well. So I'm just going through a Control Q rebuild, and you'll notice the stairs have shrunk to my new height. So you can see the power of a driving sketch and what driving sketches do, but you have to be very careful about how you do your driving sketches. This particular driving sketch, these lines that are used for the top will go from left to right in an anti-clockwise direction. The bracing lines in my driving sketch will go from bottom left to top right and bottom left to top right. That way when I go to insert my brace in there, the brace itself will have no problems. Now this is just a rebuild that has to occur here. Okay, so you just go down into the lower level assemblies and open them up and just do a rebuild, and that fixes it. In SolidWorks 2012, you used to be able to do that with no problems, but for some reason they've stopped a particular rebuild from occurring at a lower level. But that's okay. You just go into it. So I'm just suppressing items that are associated to this, and I'm just going to show you how we have member sketches inside columns or inside members and inside connections, and how they work together. So I'm just going to go back in here and add a new column. That column that was in there was all fudged up and a bit of a mess, so I don't want to interfere with that column. Okay, so you'll notice down the bottom here I have a driving sketch that is out of whack. So I'm just going to go in there and change the driving sketch. If I pick that line there and hit my edit sketch, you'll see that there's a 200 out to the left. Just make that 50 because I know it's 50. I did the sketch, so it should be 50. Now what that does is, let's have a look at how this connection is created, right? We'll isolate the connection. So that's the connection. You'll notice that for me to find things, I click on a plate and then I traverse up. The nearest assembly is the connection. The next nearest level is the weldment level, and that's how I find things relatively quickly. Now I'm just going to isolate these two so that you can see how they work together. So inside my connection, let's open up the connection. Okay, I have, and that's not labelled right, by the way. It should be member sketch. Not what to do, what you should be doing. This is an old library column. I believe the new one's been fixed. It will not be like this. I'm a bit like a plumber sometimes, you know. I do work on everyone else's stuff but not my own. So I guess looking at this, you can see that there are member sketches associated to the plates that are in there, and they actually drive the plates so that I can set that up to move around. So if I was to go into let's just say I'm going to grab this one here. And if we were to drag that, the plate automatically updates because the plate's attached. Now we have a driving sketch down the bottom here, which is associated to which the plate is associated to, and it actually drives the plate. So the whole plate is completely incontextually referenced to that driving sketch. So the whole shape of the plate and its driving sketch is loose. Now I've got blocks set up that I drag out of my my library within SolidWorks off to the right here. So if I go into my blocks, I've actually got blocks in here that I can use, and I've got bracing blocks, cleat blocks. And this is one of them. So I'll just see if I can get that up. So that's these guys here. So all I do is select the plane, drag it on, right, attach it to my member sketch, attach my plate to this driving sketch here, and it's all attached. So it means that as soon as I go to change the slope, the plate will automatically update. Obviously within reason, because if you don't do it correctly, it'll break your plate. What I mean by that is, if I open this sketch up and edit it, and did I edit it? Do that again. Edit the sketch. You'll see that the clearance for this particular brace that I've drawn in here, to which is just an angle brace, and it's got a gauge and 100 mil. That whole brace that's set up in that driving sketch has a 20 clearance on one edge. Obviously, if it becomes acute from the base plate to the slope, you want to put your 20 clear on that edge. So you literally have to switch between the other. You could label it. If this, you know, put a little bit of text in there. If this is less than 20 clear, or whatever your requirements are for your country, turn me on, and then on the other one, if this is greater than 20, turn this one off. So just yeah, between the two. So it's just a matter of just putting a dimension in here so you can see. I can't even use that feature for some reason. It's not allowing me to grab the right mouse click circle. So I'm going to leave this dimension driven, so that, and then you can put a little note on here that says if this is less than 20, make this driven. If that's greater than 20, and so forth. So you can switch between the two of them. Okay, that's for setting up your plate and putting your plate on a driving sketch. And obviously the member sketch that's associated to this plate, we're going to snap on. So we get out of the connection, and you'll notice my member sketches are all here. For my connection, I select the plate and I go up. there's my member sketch. So it takes me straight there when I select the plate. Now I've got everything in isolation because what I want to do is I want to attach my member sketch to my driving sketch and just make them parallel. Okay, now that's linked to my driving sketch. So if I was to change the height of that structure, that would update up to a certain level. I'd have to still go and check it because of the switching of clearances. Right? Cleats that I don't want, I usually suppress or delete. It's up to you on how you handle them. So I've just suppressed them out of there. And also on this side, there's also another sketch here that we need to use, and we need to make that relate that as well. So I just go collinear or equal, either way, it's up to you. Collinear or parallel, sorry. And now that cleat is associated to the driving sketch. So when I go up and I change the height of my main driving sketch at the top level, okay, and the height is driven by this, not 300, 3200, too quick for my own good. Then we zoom back down in here, and then when I do a rebuild, you'll notice the cleat changes. Okay, that parametric behavior can save you a lot of time. However, every time you go to change a dimension, you should check everything that's associated to the change, primarily because there is a sketch in there and we are human. Just got to be careful that the sketches are all updated to match. Now, you'll notice that my column, okay, is vertical. You'll notice that the section is vertical. Now, all our columns, when we deal with columns, we do that. That's by default what we do with TSD because you want it vertical. However, on the drawing, because our drawings are landscape, we lay the column over. And there should have been a setting in here as well. If you don't want to see things when you make changes or suppress things and you don't want to see them, go into your document properties, go to detailing, hide dangling dimensions and annotations. And that tidies your drawing up and gets rid of all the dangling dimensions. Not gets rid of them, but hides them. If you want to turn those plates back on, those dimensions will come back. Nice little tip. Anyway, you can see how that column's done. So let's go in and look at our braces. Okay, because our braces are going to be sloped, they are still drawn horizontal, even though they are positioned in here diagonally. Okay, I open the drawing up that's associated to that. It's horizontal. Right? It means that the actual component, if I go down into the assembly, okay, it's horizontal, and the actual member itself is horizontal as well. Now, we've done some shifty little things with this brace to get it to work nicely. So when we go down into this connection, we've actually got a bracing sketch that we have that we can turn on. That one there was the first one on the list. We go to the brace. Okay, notice I've selected the brace. That highlights the assembly to which it belongs to. And down here I've got a left cut and a right cut. If I go to the left cut, I can go in there and you'll notice that it's got fixed dimensions. I can either hide that or turn that dimension off by going over here and making it driven, or I can just simply go delete. Now when I'm done, I don't want to have all these dimensions in there, so I just go delete. What it means is that the end of this brace can move wherever I want to put it. And I can simply just select the cut line that I've got in there and the sketch line to which I want my brace to go to and make them so that they are collinear. And now my brace will be attached. I've already preset my brace to have 70 centers on my holes, so I know that when I go to insert that brace, it's always going to be right. I also have in my braces a cope. If I don't want the cope, I simply suppress it, and the dimensions associated to the cope in the drawing will disappear because I've got my dangling dimensions turned off, or turned on, sorry. That's pretty much how you can get yourself a braced connection fairly quickly without having to go through the process of starting from scratch. And if you've done that in a multi-bodied environment, dragging and dropping items in, it can be a bit slow. That's fairly quick, as you can see with what I did there. And that is all parametric, by the way. So you can see the power of how a driving sketch and attaching members to the driving sketch actually works. You can see how member sketches inside the welded member and the section and the connections work as well. So let's just go back to the slide and just make sure we've covered most things. I think we've got one more to do at the end. So you've seen how a member sketch segment snaps to a driving sketch. We've covered that. We've covered that there are 3 mates. I haven't shown you that. TSD automatically mates these into position. Okay, these are the 3 mates. So what it does is it grabs the origin point. So when you do your member sketches, your origin point is where your member sketch starts from. If I open that member up, you'll see that my member sketch starts from my origin point and goes from there to the left. And also too, you'll notice that inside this we have another sketch to which this member is attached to, which is member sketch doesn't have to actually overlap. They don't have to be on top of each other. It depends on how you set it up. This is the offset for the thickness of the cleat plate. Okay, and there's an offset plane that's in there that adjusts this so that you can move it in and out. Okay, so you don't necessarily need to overlap them perfectly, but when you use TSD it will do that for you automatically, and then you have to break them if you want to put in some sort of arrangement. I could have, in this one, created another sketch similar to that other one that I did with an offset sketch with a dimension on it that could drive the actual position of where this sits, and then when I insert my brace section into my welded member, I would attach it to the driving sketch that is attached to the member sketch in the welded assembly. I know that might be a little bit daunting to some, but it works, and it works very well. I'll show you in a sec with a truss. How does that sound? So you can see that through the process of inserting sections, you can move them just a little off center if you need to actually get the offsets that are required. And obviously if I change the thickness of this plate, I've got to change the offset associated to that member, and they are not related in any way, shape or form. Okay, now I'll show you how this works again, but I'll put a truss in so you can see what happens with trusses. So if we go down to trusses, we put in a horizontal truss, and you'll notice this has a driving sketch in it, in the truss. So the trusses come in, do a rebuild, and this used to be a straightforward rebuild, but now sometimes we actually have to go into the actual pattern and just do a rebuild on the pattern. Okay, but that fixes that straight away. It could be the way that this has been set up. I think these have been fixed so that they automatically update. However, there's an equation in there that drives this. So in here you'll see that I have a member sketch, which is the first segment, and I've got a dimension on it, but it's driven. I also have a depth sketch which sets out the bottom chord for the truss. So I've attached the bottom chord to that, and I've attached the top chord to the member sketch to create this truss. And then inside it we've got these diagonal horizontal chords, we've got diagonals, okay? And in there we have other sketches as well, because the sketches themselves have to be positioned based on, you know, offsets based on the members. And you've got to be very careful about how you do these, because you don't want to go creating circular references on your rebuilds. You'll soon find out, because it'll be a pain. And you get that nice little rebuild symbol that'll pop up, and sometimes that doesn't always show either on your circular references. So you can see how using offsets we can set up other sketches. So we've got other sketches that are associated to how this whole truss works, and there's patterns in there and dimensions that are driven with an equation. Okay, there's the equations that are set that up to get that to work. So you can see how everything hangs off that one member sketch, and that one member sketch drives the entire truss. I can obviously change the height of it if I need to by going in and just doing a rebuild on that. That's pretty handy, pretty quick. And also with that truss, you know, there's a drawing that's associated to it, which is already there detailed. So you can see how we can dangle other sketches off our member sketch so that we know where to go if we need to change things. Okay, so that's how we can reuse sketches within member sketches as well to drive things. So you're not just limited to just using the member sketch. You can add other sketches in there. All right, so that pretty much covers that. Let's go back to this slideshow again. Now, multiple member sketches in the one. There, you can do this yourself. I don't have an example that I can think of off the top of my head, but if you want to go and add, say, at the top of the stairs, you could create another driving sketch, another member sketch, sorry, that you manually snap on to a line. So you can do that and just call it member sketch 3. So when someone inserts this, the process is to obviously open up the welded member, and in your image obviously you're going to have, you know, a line that says number 3 on there, so that they know that they have to, when they insert it, that there's a third sketch. These images, by the way, when you upload to the library, you can go into the library's pictures area and use paint and do whatever you want on them. Just be wary of that. And you also notice that ours are nice and pretty because we use PhotoView 360. It's actually a 200 by 200 bitmap. Okay, now the rules for the member sketches we've covered. The obviously the truss and how they are, the member sketches in how trusses work and how member sketches work in connections. That's where the connections are. We've covered that. So last but not least, let's cover this multidisciplinary project driving sketch process. I have an example, but it's not fully complete. I'll get out and I'll show you how it's done. So if we log into a project, now I'm logging into a project, I actually log into the area assembly of the project. Okay, you'll notice that when I log into my area, I've got a driving sketch in there, and if I go over to my other area, I've also got another driving sketch in there. If I go into the first area and log into that, you'll notice some differences in the way that things are done. Okay, this is an area assembly. Okay, if I open and I go to the actual project that's there, I think it's 004 under 2014. Okay, and there's the top level assembly. You'll also notice that there's a DSO1 there. Okay, the naming conventions for a top level project area can be anything you like, but for consistency reasons, if you need help, we have to come on board and give you some support. If you name them the same, it's easier for us to help you. We don't have to work out what's going on. We can go, okay, well, that's your top level driving sketch. We know what that is. So for consistency reasons, we name it the project number, and then DS01 means driving sketch 01. This is a project driving sketch. It means the very, very top layout for a multidisciplinary project or a multiple area project is driven by this sketch. Obviously the area project, the top level project, we drag the areas in manually into that top level project, and then we position them through mates manually to the driving sketch inside the top level assembly. And we also put the driving sketch inside each area to position it. What I mean by that, and I'll show you so you can see it. This is an area. I should actually go back to that, and I've got to get Travis back through again. Sorry, I should have opened it up. TSD projects, open up that assembly. Okay, so this is the top level assembly, and basically I've got my driving sketch, which is the top level project driving sketch. Okay, now this is deliberately set up so that if you've got a team of people and your lead project draftee is the only one that has access to the very, very top level assembly, primarily because you don't want everyone in there, especially if you've got 10, 15 people working on a project. You want to be able to have that managed so that nobody get access to this main driving sketch, because that can cause disasters. The reason for that is because if I go into this driving sketch, everything is actually set up off that. Everything. So if I go 40 meters here, I've just simply moved it. That main driving sketch is really important for major layouts and major projects, okay? And you'll have your grids for things like plant layouts. Now, inside that, we've got our two areas, which is what we log into. Okay, it's the most common area, or most common assembly. We actually log into that, and this is where, if you've got a team of people, they'll be working in different areas. okay? And each area, depending on how you set it up, in the past I've set it up so that area AB is the structure, and then you might go area AC being, and you would put them in folders obviously and name them at this level so that you know what they are. So area AB would be structure, area AC would be piping, area AD be civil, and you'll notice that I'm keeping the A, and obviously B is a second structure within the same project, and then I break that up into, you know, area B, BB, which would be piping, BA structure, BC would be say something like civil or mechanical or anything like that, okay? And that's basically how we use areas at this top level. Now if I open up my top level, my area level, which I would normally log into, you'll notice that the driving sketch for the project is in there. Now the driving sketch for the main frame is at a position within origin, okay? You do not want to have your main driving sketch sitting at origin, because if someone changes the position of your main driving sketch, all your drawings are going to go out of whack at this level. You don't want that to happen. So basically what we've done is we overlap or overlay the DSO1 so that the position to which it's attached to, in this case is right there because that's where the origin is where it would be related to in the top level assembly. So what that means is if I was to go and drop area AC, not AB, over the top of this one, you will notice something very interesting, because you actually have to position the driving sketch at its origin to get them in the right locations at the top level assembly, and that's basically what we've done. So in an area, you want to make it so that each one of these areas at this level, if you're going to create a GA at the area level, you do not want it moving, but at this level you have to have it moving. And to do that is to just simply overlay the driving sketches and mate them together. I don't know if you guys understand exactly what it is that I'm doing there. If you do have any questions around that, please feel free to ask me. I can cover that quite in depth. We could even do a complete webinar on it. However, it's not an advantage to anyone unless they are working in a team environment, because it's about managing how multiple people can work on a project. So basically, if you've got, let's just say AB, AC, AD, like I said, you've got civil, mechanical, piping in different areas, it means that disciplined people who work with piping can drag the structure assembly into their project, locate it using the driving sketch, that way it's in its same position, and then they can make it so that it's read-only and they're not actually going to affect the person who's working on the structure while they're doing their piping, and they can work around that structure that's already in there. And if anything changes, they get notified that there's a change, they can update and have a look at it. That's about how we handle that multi-discipline process, because you do not want to be there going, who's in the model, get out of the model, who's in the model, get out of the model, because that's just crazy sort of behavior, especially if it takes you, 5 minutes to open up a model if it's quite large, and you don't want to get in and out constantly because someone's in there. So this is more about managing how your assemblies work and how multiple people work together in a project. The driving sketch that's associated to this frame could also be created and put into your, your civil or your piping, so that you've actually got the frame there to which you can attach a new driving sketch part into and then add the piping to. So that's a really good setup for people who work in multi-user environments. All right. So I think that pretty much covers everything in today's webinar. Before I get people to ask some questions, obviously right at the end of this, what I want to do is for questions and answers, if you've got anything that's really particularly crazy and out there and you've got what-ifs, please send them to support at the Steel Detailer. We've got a group of people who can answer your question fairly quickly, or you can send them to me personally. If you're familiar with me, you've got my email, just send them to me personally and I'll be happy to answer them. If you've just got some basic questions about some things that I can show you, sure, shoot. So what I'll do is I'll take you off off mute. And if you haven't been able to get in to talk, it's because I accidentally sent you the wrong pin. And to get the right pin, there it is there. Okay, so are there any questions? No news is good news, guys. If you've got anything, please speak up. Wow. Okay. So that's good. I think I've covered that pretty much in depth. Either that, or you don't see a benefit in some of it, or you do see a benefit in it. However, when you come to doing this yourself, I'm sure the questions will come. By the way, we've got a special going for people who are interested in buying a seat of TSD. Obviously, I've got to do a sales pitch at the end. I'm sorry, but it has to happen. You get this free stuff, so it's great. And we're offering TSD for 30% discount, and we're giving you a week before the next webinar. So obviously, if you keep continuing coming to the webinars, we can keep giving you the opportunity to be able to take on that discount. And if you're a reseller, we're happy to negotiate something with you guys as well. So I really appreciate all you guys getting on board and having a look at this today. I really appreciate the time that you guys have put in. I know some of you are very busy people. The next webinar that I'm going to present is obviously going to be a doozy for some of you, because not a lot of you have probably gone past this part or gone this far that are on. I'll soon find out, because when I send out the webinar, people will jump on or not jump on, and then I can get a bit of a feel as to whether or not it's suitable for them. Okay, seeing that there are no questions, if you do have any questions later, feel free to certainly ask them. This is being recorded, so the recording will be put in our customer portal for our customers, and for those that attended, we'll also send out a link so that you can watch the webinar. Okay, so that pretty much concludes today's webinar. Thanks very much for your time, guys. And for those that are at home in the evening, enjoy the rest of your day or the rest of your night. And those that are just starting in the morning, thanks very much for your time and enjoy your day. I'll catch you later on the next one, guys. Thanks for your time. See you later.
Thanks, Malcolm.
Oh, thank you.
All right.